Hey everyone, welcome to From Zero to Broad in 2 months. Happy to have you here. Let's begin by telling you a bit more about me. My name is Maria and I am a career changer. In my past life, I used to be a nutritionist, and around 4 years ago, I decided to go all in with the programming courses I was doing on the side. I got into a web development bootcamp in Mexico City, and right after it, I got my first job in tech, where I was cornered into figuring out our cloud setup in AWS, which I only had a faint idea existed, and slowly became the DevOps there. And since then, I have intentionally continued to pursue this path. I met Kubernetes last year while on my former job at Pento. You can see now I work at Sticker Mule. And it is in Pento where this journey takes place, from starting to learn more about Kubernetes, passing the CKA, and attending my first KubeCon along with my colleague and friend Gabby. So far, it has been a great ride, and this is where the Linkerd adventure takes place. And well, but to be honest, along the way, the cloud of unknowing has been the one I have spent more time navigating and getting used to exploring, learning, figuring out stuff, and asking for help. And this is also how my Linkerd adventure started, with me knowing zero about it. So let's move on to setting the scene. What was going on at Pento, the company I was working at the moment? It is a fintech. It operates in a regulated space where security is a big deal. So what was going on now in the platform team? At that point in time, we were 3, and we were implementing a GitOps pattern using Argo CD, which also meant that we were moving away from doing any manual steps in a mindset of automating as much as possible. So later down the line, I ended up being a team of 1 after some unfortunate events involving layoffs, hence the title of this talk. So sometimes you will hear me talk about we and how I did get help from my team during the process, even if I was the one responsible for the project. So now let's go to the engineering team side, where the Catalyzer event takes place. So around Q3 last year, our engineering team started breaking down the monolith because we're moving to a microservices architecture. So that means that up until that point, it did not make sense for us to have a service mesh. In fact, quoting material from the Linkerd course, because a service mesh works by operating and measuring the traffic between services, it is only really useful in a microservice application. Cool, now we needed it, and to be more precise, we were primarily interested in the set of features around security. So mutual TLS, so we could move towards a zero trust security approach, which was also a push from some of our customers. It would also help us make sure the communication between services was encrypted, preventing any other actor that could potentially infiltrate our network to intercept that traffic. We wanted to take that from the engineers' plate, who were busy breaking up the monolith, bug fixing, and feature creating, and did not have the time to implement service-to-service authentication for each one of the new services. And quite frankly, why would they when a service mesh can do it even better? So with MTLS in place, we could enable client-based authorization and control traffic to mesh pods in a more granular way using authorization policies on top. Okay, so we had established we needed a service mesh, but which one should we implement now? So we knew it had to be simple to install and maintain. And service meshes in general are well known for being tricky to get right. And we wanted to avoid dealing with unnecessary complexity, since the only resource available to take on the implementation was me. So also my manager had experience working with Istio before, and his life was not happy. The feature we needed, authorization policies, had been released into Linkerd the previous year, so we were good to go on that side. In summary, we did not have the resources, the time, or the confidence to run the alternative. Linkerd had all the features we needed, and they had us at the ultra simple part. So due to all the previous reasons, while we were at an unofficial team offsite working in Spain, and after wondering for a while, my manager said, "I want to try Linkerd." And I said, "Okay, I'll do it," trying to appear as confident as possible. So let's get into it. Here I will cover quickly and on a high level the beginning of the process, where the goal was to have a proof of concept working as fast as possible in our staging environment. And I am putting a pin in the things we are coming back later. So to get started, I'm pretty basic. I used the 101 Linkerd tutorial along with the guys' introduction to service mesh and getting started. So to test in my local environment using Minikube, Linkerd CLI, and Emojivodo. That was super fun. But it was time to put the Linkerd CLI aside, because in our particular case, we used Customize instead of Helm to manage our infrastructure resources. So I then invested most of the time getting right the templating by tweaking the values.yaml file to adapt it to our needs. Considering we already had realized we wanted to leverage automatic certificate rotation, so there is the GitOps mindset already creeping in. So I faced my first bump in the road as soon as I deployed into staging. I had an issue with the proxy init containers not initializing. So, long story short, using the Docker container runtime instead of containerd, you need to set the proxy init container to run as root for it to work, so it is able to update IP tables. I also wanted to have the dashboard you get by installing the Linkerd Viz extension, which was useful to see what was going on while we started meshing namespaces. And here's where we faced our second bump, which was figuring out what was happening with our cron jobs, but more about this later too. Okay, so after validating our assumptions and making sure everything worked as expected in staging and demo environments, we started getting ready to deploy Linkerd into our production environment. So I found two resources to be really helpful at this point, and went ahead to create our checklist using Linkerd in Production 101 and Buoyant's Linkerd Production Runbook. And we can divide the tasks that we tackled into two different kinds. One would be preparing our system and Linkerd to be ready for production, and the second one would be setting ourselves for long-term success managing Linkerd, which were tasks mainly related to automation, documentation, and monitoring. Okay, so I will start covering each one of the tasks we tackled to get our system and Linkerd ready for production. So the first one of all would be run the automated checks. Sounds pretty obvious, but it is easy to forget about it, and it can save you a lot of headaches. In case you're using GKE, review your firewall rules. We previously had updated those to allow certain ports in all of our environments, so we could go ahead with next steps. Then use Customize or Helm to deploy Linkerd. So the Linkerd CLI with Linkerd install are really convenient to get started and test locally, but for a repeatable and automated approach, we used Customize in our clusters from the very beginning. And I would highly recommend using this approach early on in your journey so you can figure out cert management, flags to use, what custom overrides to include in your values.yaml files you need to pass when using Helm install or Helm template to obtain the manifests. So using your own image registry is crucial when deploying Linkerd in production. We did encounter problems while pulling images from the public GitHub repository, which led to failed deployments in our ephemeral environments. So to address this, we decided to host the images in Google's container registry, pulling them from the public registry and pushing them to ours. After further evaluation, we discovered that the most efficient way to specify the new images for each Linkerd component was to update the values.yaml file instead of trying to use patches. This is really important. Enable high availability mode. Some important features of this mode are it replicates critical control plane components, and along with anti-affinity rules, you can distribute those components across multiple nodes and even different zones. And also sets resource requests and limits on control plane components and data plane proxies. It also requires the proxy injector to be functional for any pods to be scheduled. So HA mode adds this restriction in order to guarantee that all application pods have access to MTLS. So it is very important to add a label to the kubesystem namespace so the Kubernetes API server will not call the proxy injector during the admission phase of workloads in that namespace, allowing system pods to be scheduled even in the absence of a functioning proxy injector. So to enable HA mode, you can pass the values -HA YAML. Also, the Linkerd extension supports enabling an HA mode too, with similar characteristics to the control plane one. Finally, this one is super straightforward. The Linkerd control plane has its own data plane proxies and should not be injected. To avoid this, you can annotate the namespace to disable injection. Okay, so to make sure we were successful managing Linkerd for the long term, the most important step here was making sure that we had set up automatic rotation for the webhook TLS credentials. We already had automated the control plane TLS credentials using Cert Manager, so we based this task on what we had done previously. Next, I needed to make sure that everyone else knew how our cert management strategy worked, including the duration of each certificate. And also, I documented how to debug Linkerd with links to the official documentation for more in-depth knowledge. For monitoring and alerting, we were combining the usage of Datadog along with the Linkerd Vis extension, but we were looking forward into improving this, although it was not a priority at the moment. Okay, now I want to focus on the main bumps in the road that we transformed in stepping stones along our way, as Bruce Lee says. So the first one would be figuring out the issue with the cron jobs. Weirdly, our test authorization policy setup was not working, and cert management, which for me it is the most important one, mainly due to the consequences. One of them being if you fail to rotate them in time, certificates expire and you will have downtime, which is not good. Cron jobs. So this was a minor pebble we found in our way, and it is not a Linkerd issue by itself. It is more of a Kubernetes issue. So what was it? After we started meshing namespaces, we noticed that the cron jobs we had were not being removed after running. The reason is that jobs are supposed to terminate, do their work, and exit. But if we have a sidecar container like the Linkerd proxy that continues to run, the pod will never exit and the job will never finish. So you will get an endless list of pods still running, which uses up resources and spikes up costs. So how we worked around it? After searching in Linkerd Slack, we found out that there are several options to consider, but at that point we went for the more straightforward one, which was to add an annotation to disable the meshing of said resources. On a hopeful note, while I was preparing the talk, a friend sent me an article that details a more definitive solution is on the way, and it might be available in a future Kubernetes version. So if you're curious, you can go check out the corresponding Kubernetes enhancement proposal. This one is short but not sweet. It was a slippery stepping stone and a bit embarrassing. We spent a lot of time figuring out why our test authorization policy setup was not working, with the first request succeeding and then all the rest failing. So super weird. Whether you do it imperatively with kubectl, like in this example, or declaratively with a manifest, you need to set the container port for them to work, specifically for the server. And voila, they work after that. Okay, certificate management. So there is another set of certificates to manage. That was me when I realized, while going through Buoyant's Linkerd production runbook, that besides the control plane TLS credentials, there is another completely separate trust chain used by Linkerd's control plane components named webhooks. So what does this mean? Well, basically Linkerd uses different sets of TLS credentials for securing communication. The first ones I encountered and got familiar with were the control plane TLS credentials, and those are used to secure pod-to-pod communication, making possible identity management for mutual TLS. Now, the webhook TLS credentials secure communication between the Kubernetes API server and the Linkerd control plane components called webhooks, as well as Linkerd Vis and Jaeger webhooks. You can see here the two trust chains and its components, and next I will explain in a simple way, hopefully, how each of them works. So let's zoom in the proxy containers here. In Linkerd meshed workloads, application containers communicate through the Linkerd proxies. So these proxies used the signed certificates to establish secure communication, authenticating each other, and encrypting the data in transit. Now, it's the turn of the webhook TLS credentials. So we have on the left the Kubernetes API server, which, as we know, is a central component that manages the overall state of the Kubernetes cluster. And on the right, our Linkerd control plane, which has different webhooks like the proxy injector, the service profile, and policy validators. So in this example, we're going to focus on the proxy injector, which is a mutating admission webhook that automatically injects the Linkerd proxy into Kubernetes workloads when the corresponding annotation exists in their manifest. So the communication process involves the API server sending an admission request, like in the example saying, hey, I am going to create a pod, to the proxy injector, which evaluates it and potentially modifies or mutates the workload and sends back to the API server for deployment saying, cool, make sure you add these two containers too, the proxy init and the Linkerd proxy. So now that we have clarity around why we need certificates and what they are securing, we can have a look at how we automated their issuance, renewal, and rotation. The central piece of this puzzle is Cert Manager, and we already had it running in our cluster. So we integrated it to bootstrap a custom certificate chain of trust so that we could make the Linkerd installation process more compatible with a GitOps style deployment. For example, and referring to issuance, I mean that when you install Linkerd via Helm or Customize, you need to pass certificates along for it to work. And we wanted to avoid having to manually generate a certificate to pass it via arguments. We just wanted a more declarative approach, so to have the certificate in the cluster and use it. So besides creating the resources, you can set their duration in the manifests, which depending on your security posture, you could set different values on each environment. I am leaving you here also the workshop and the repository used to accomplish this task, and again I will proceed to explain with the diagram. So by using Cert Manager and the Trust Manager plugin, you can automate the management of the entire certificate lifecycle. In the Cert Manager namespace, it will create the Linkerd Trust Anchor, which is the root certificate authority for Linkerd. Now, using the Trust Manager plugin, we can distribute only the Trust Anchor's public key to the Linkerd namespace, leaving the private key secure and constrained to the Cert Manager namespace. Now, going over to the Linkerd namespace, the identity service acts as an intermediate CA, holding the Linkerd Identity Issuer Certificate, which in turn has also been signed by the Trust Anchor, thanks to the public key we made available. And finally, every 24 hours, each Linkerd proxy sends a certificate signing request to the identity service, getting back a signed certificate so that they can authenticate themselves and participate in mutual TLS. Cool, right? So, okay, that was a lot to cover. Just wanted to leave you with some final thoughts, the main one being that Linkerd is made by super smart humans who make it so simple for us mortals to run a service mesh and not die trying. Sorry about that, just needed to say it. Now, in a more serious note, the adventure of getting Linkerd into production was super fun. I learned a lot and had the luxury to invest a lot of time learning about how it worked. Having a great manager in that sense is truly a blessing, someone that trusts you to deliver and to have your own process of learning. So if you're a manager here, give your peeps some space to explore, learn, and take their time. I am sure they will appreciate it and deliver great work. So I hope you're inspired now to try Linkerd in your own cluster or even locally, and that you can approach it even better than I did, just by being aware of some gotchas and tackling certain challenges like cert management early on. So remember to add yourselves to the adopters list as you have Linkerd in production. It felt amazing. And last but not least, a huge thank you to Brendan, Gabby, Megan, Flynn, and Catherine that helped me get here. And a special mention to Marito, who is my very first mentor, is sitting in the front row. Here I leave you a lot of resources that I used to get this to work. You will get the slides too, so you can just go through each one of the links. And yeah, thank you for bearing with me for almost half an hour. You're amazing.
Once again, we do have a few minutes for questions. Anybody have anything? Yep, right there.
Hi. Not really a question. I was recently asked to look into why jobs and cron jobs were hanging too in the mesh, and they didn't allow me to remove them from the mesh like you did, which would have been preferable. But there's this thing called linker await. Just give you feedback. It works. You can fix it with it.
Sorry, I did not get the question that well.
Yeah, it wasn't a question. I was just elaborating on the issue you had with jobs and cron jobs.
Okay.
Yeah, just saying, if you don't want to remove them from the mesh, there's this thing called linker await, right?
await,
You
yeah.
can wrap your job with it.
Yeah, that would be a great option. And yeah, thank you for telling us.
Anyone else?